Okay, so this next section, today we're working on finding the area under a curve given a table. Okay, so they give us the table of numbers. They give us all our y values. And what happens is, since they give us all our y values, great, they did all the work. I don't need a plug, I don't need a graph. Now this first section, I ended up showing you guys what the graph looks like. So this is some function, some smooth curve, or some curve in general. So their version of this like cubic drawing here is not realistic. What it is, they're just mapping out the points that are given here. Okay, that's what they just mapped it out. But what we're going to do is we're going to go ahead and steal these points and say, hey, between 0 and 1, what is my approximation there? Now we get to choose left hand or right hand approximation. These will all be done using right hand. The next problem will be done with left hand. So with the right hand, between the values 7 and 8, take a look. That's 7 and 8, right? They wrote that in the table. Which would be the right hand? The 7 or 8? On the right side, hello, left or right, you would choose 8. That's why the picture is drawn a rectangle at 8. Between 1 and 3, which one would be the right value? The right value would be 6. Okay, that's why we're using 6 here. It's not the greater value, it's what we determine the value we want to choose. And we want to choose right hand, so we're sticking with right hands here. So we're going to choose the 6. Now, also please be aware that the distance between 1 and 3 now is 2. So the rectangle here is actually 6 times 2. The first rectangle was 8 times 1. The next rectangle between 3 and 5, that space is going to be 2, and we're going to choose either between 4 or 6 or 4. We're not choosing which bigger, we're just choosing which one is on the right side of that. So the which one on the right is 4. So this is going to be 4 times 2. As you can choose between 4 or 6, we're always going to choose the right side here. So that's what we end up with, a 4. How about between 5 and 9? Last one, 5 and 9. Okay. We're going to choose our right side. We're going to choose between 4 and 6. We're going to choose 6 here. And the base is going to be 4 spaces. That's 4 spaces here. So it's going to be 6 times 4. Okay, extremely difficult, right? No. Hopefully all you people with the heads down, you are actually doing the work right now. Doing the work of angels. Good. So we just added. So we said this was going to be 8, this was going to be 12, this was going to be 8, and this is going to be 24. We add those up. 36 plus 16. 36 plus 16 is 40, 52. Right. How's this different than left? Well, right is different from left because if you look here between the choices on my next problem, between 6 and 5, we're going to choose the left option. Okay, we're going to choose the left option. Between 4 and 5, we're going to choose the left option. Okay, that's why we chose the 6 here. Between 5 and 6, we're going to choose the left option. That's what we're choosing. Between 4 and 5, we're going to choose 4 here. Between 6 and 8, we're going to choose the numbers 5 because it's on the left. So 5 and 3, we're going to choose the number 5 and 3 down here, right? We're going to choose 5 on the left. Now the only thing is you have to make sure is that these are rectangles. So base times height, we have our heights. You want to make sure you get those bases right. So distance between 1 and 4, that was 4. 4 and 5, that was 1. 5 and 6, that was 1. 6 and 8, that was 3. So in the picture, obviously you can see this is 5 times 4, right? Yeah. But if I just give you the table, I want you guys to notice that too. For these two sets of numbers, are we going to use the y value of 5 or y value of 6? We are going to choose the y value of 5 because that's on the left side. And because I asked you for the left-hand Riemann sum. What's the base? Between 0 and 4, that's going to be 4. So 4 times 5 is 20. Between
Mr.
4.
Oh, if we have, oh, sorry.
No,
If
go
we're
ahead. Go
having
ahead.
a hard
Please.
time visualizing just based off the chart, we can always draw the
You
graph, right?
can. If I had to draw a chart, I would just draw the dots. So if I was drawing this right here, okay, I would draw 0, 4, 5, 6, 8. Something like that. 0, 4, 5, 6, 8, right? Right? And then just graph the y values. This is 5. This is 6. This is 4, a little bit lower. This is 5. This is 3. Just draw the dots. Please, just draw the dots. And then we pick the left dot.
Is the chart always going to be rectangles?
They will tell you what to use. In this case, they want us to use a left-hand Riemanns sum approximation, and that will be rectangles. Riemanns sums will always be rectangles for us.
So there is a way to do it with other.
They will tell you what shape. Yes.
Shapes?
If they say trapezoid, use trapezoids then.
How would you do that?
To the trapezoid, let me give you the example with just the first two. Okay. To find the trapezoid, it's going to be 1/2 base h1 plus h2. Are you okay with this equation for the trapezoid? So it's 1/2 base. What's the base? That's 4. And the height is 5 and 6. And that's our first trapezoid. And then you would go into your second trapezoid, and then your third, and then your fourth trapezoid. Does that answer your question? Is that okay?
Could you do the first one, like this trapezoid, so I can visualize it?
Sure. So if I'm just using, let's use the picture that they drew already. The left value is 5, and the right value is 6. And this is the trapezoid. It's already done. So the left side is 5. So that's why you say 5 plus 6, right? And then the base, what's the base here? The base is 4. And we
Okay.
1/2 that.
I get it. Thank you.
Mr. Ko.
Yes, Naman?
So this, you said this is the left hand, right? So how is this differing from the previous one, the right hand one we just did,
So,
using that chart?
okay, good question. It's all about which choice are we going to use. Because both 5 and 6 here, both 5 and 6 are not bad options. But we just want to make sure that my answer is the same as your answer. So if we all say left, we all choose the left value here. If we all want to choose right, we choose the right value. So
Alright,
for
thank
every segment, we make that choice. So the first segment here. So for the first segment here, you get to choose 5 or 6. Since we decided to be left hand, we would choose 5. That's why we're 5. Between our next segment, between 5 and, oh my gosh, between 6 and 4, we're going to choose 6 because we want the left one, right? That's why this is up here.
Alright.
Between 4 and 5, we're going to choose 4. That's why we're down here. Between 5 and 3, we're going to choose 5 because that's the left.
Alright, thank you.
And that's our y values for our rectangles. Now, if they give you something like this once again, and you want to visualize it, please don't go super detailed. You just need dots. And the dots would have been 5, 6, 4, 5, 3. And if you can see how detailed and how accurate my drawing is, no, it's just 6 is higher than 5, and 4 is lower than 5. Just get those dots kind of right. But even if you don't get the dots right, if you just write the number 5, 6, 4, 5, 3, that'll save you a lot of headache, honestly. If I choose the left side, that's going to be 5, right? Choose the left side, that's going to be 6. Left side is going to be 4. Left side is going to be 5. And ignore the 3. That's on the wrong side. And the base, 4, 1, 1, 2. Right? 4, 1, 1, 2. We're just using the table to steal y values and base values, which is kind of nice. And the reason why we have left and right is because left and right, of course, will be different answers. We just want to make sure your answer is the same as my answer. Is there a better choice? There is, depending on what you want. Once we learn about increase and decreasing functions, we can tell that if a function is decreasing, let me just actually show you right now. If I give you a idea here, if a function is decreasing, okay, see how it's decreasing, all right? If I make a left choice, it will always be a over or under approximation. It will always be a over, because every step is the loser step, right? Next step you take is going to be less. So you should have bought, or you should have sold when you should have, right? That's always going to be bigger. But if I do the same exact graph and I make a right-hand estimate, right, that's always going to be under because it was lower than your previous value. You can think of it that way. If I'm losing money, every second I wait, it's going to be less than the second before. I should have bought yesterday. I should have bought stupid AMD yesterday. I should have bought Bitcoin yesterday. Darn it. Okay. But if it's going up, if my prices are going up, every point on the left is always going to be lower than that of the right because we're increasing. So you can make a prediction if this was going to be over or underestimation already if you know if the graph is increasing or decreasing. So there are sometimes we want to underestimate, sometimes we want to overestimate, and knowing if the trend is increasing or decreasing and left or right approximation, we can make that assessment. We can make that choice. Okay, so if we look at the next type of question here, I didn't give you a graph, and maybe that's better for some of you guys, so the graph might have confused you. Okay? But if you look at my first rectangle here, I want you guys to use the left-hand approximation. The left would be 4 or 3. That would be 4. Now, sometimes people get confused because they put the x's on the bottom and y's on top. No, x's on top and y's on bottom. They flipped it around. And there's nothing wrong with it. It's just being able to make sure you read it correctly. Because when you're drawing it out, here, let me just draw it out. This is how easy I'm going to draw it out. I'm going to write 4, 3, 2, 3, 2. Those are my values. Am I going to choose left or right? Left-hand approximation, left-hand approximation, left-hand, left-hand. Ignore the last two. What's the base? The base here for between 0 and 3 was 3. That's my base for my first rectangle. Between 2 and 5, my base is 2. Between 5 and 7, my base is 2. And between 7 and 9, my base is 2. And those are your rectangles. 12 plus 6 plus 4 plus 6. And that's me wasting time drawing. I wasted maybe another 30 seconds. But if that's helpful to you, great. It is a way to help model it. You can also, another way of just looking at it, say, hey, you know what? My first set of numbers, okay, the base is 3 and the y value is 4 because I'm choosing the left value. The next set, the base is 2, right? The base is 2. And the height is, I'm going to choose 3 because I want my left number. The base is between 5 and 7. The base is 2. And my y value is 2. The base between 7 and 9 is 2. And the y value I'm going to choose between 3 and 2 is going to be 3 because I'm choosing the left value. Okay. So in these cases, there is no function given, right? That we can't actually take the integral of this because we're just given some key points along the way. We're not actually given the actual function. That's why it's, again, an approximation of what the graph would have looked like. Yeah. Easy peasy, right? Once you start to decode it, it's actually pretty easy. If you look at the next term right here, we're doing left. So the base is going to be 3. And in between choosing 5 and 3, I'm going to choose 5 because that's on the left side. Remember, we're doing rectangles, okay? So we need a base. The base is 2 between 3 and 5. And I'm going to choose 3 because that's on the left side. You can do the next one mentally. What's the base between 5 and 6? I know that I gave you guys a hard one, right? Chico, come on. The base is 1, okay? The base is 1. And will you choose 4 or 2? Hopefully you choose 4. If you guys aren't sure which side's the right side and left side, remember the Pledge of Allegiance? I put my right hand over my heart. The right hand is the right side, okay?
That's how I tried remembering it when I was in elementary school.
I still do that, Andrew. I still do that.
Me too.
Okay, it's okay. We all have ways. We all have our ways. Between 3 and 9, that's going to be the base is 3, and the left side is going to be 2. Please don't on the test tell me I got this wrong.
Could you do that again?
Oh, the whole thing? Or
Yeah,
just the last one?
sorry.
It's okay.
Defining it.
Know what? Let me do it for the next problem, okay? Actually, no, fine. I'll do it here. Just to repeat it. Sorry about that. Here we go. So, what we're doing is we're drawing a rectangle, right? And the base of my rectangle is my x value. So this is, in essence, my x value. And the g of s, that's my y value. That's my x and my y. My base and my height. So to find the base of my rectangle, between how far did I travel from 0 to 3? I traveled 3 spaces. Now, do we choose the 5 or the 3 for the height of my rectangle? Since we said left here, we choose the left value. Okay? Left doesn't mean smaller. Left just means left. Michiko, isn't 3 on the left side of 5? Yes, on a number line, yes. Okay? But the idea here is if I'm on the graph, here's 0 and here's 3, the left value is 5 and the right value would have been 3. So we choose the left approximation, not the right one. Between 3 and 5, the base value is 2. And the y value, am I going to choose 3 or 4? We want to choose the left one. That's going to be 3. And we're adding all these rectangles up. We're building some Legos here. Between 5 and 6, we know the base is 1 between 5 and 6. And the left value is going to be 4. So 1 and 4. And the next one is between 6 and 7. Our base is 3, and we're going to choose 2. Okay?
Okay, got it.
Good. Yay. All right. So these are the types of questions you guys will have. This worksheet is a scramble off the worksheet you guys will have on CUDA. Now again, just to drill this home, so I gave you a right one. Now the difference between what the problems you're going to do is these are 4. These are going to be 4 rectangles, right? 1, 2, 3, 4. And then I made your life suck by saying 6. 1, 2, 3, 4, 5, 6. All right. You can use a calculator for this. Honestly, you can literally just use a calculator. 1, that's 1, right? 1 times, in this case, it's right hand sum. 1 times 3. Hit plus on your calculator. Then this is 2 times 2, right? That's a 2. Hit plus on your calculator. 1 times 4. Hit plus on your calculator. 1 times 2. Hit plus on your calculator. 2 times 4. Hit plus on your calculator. And 3 times 5. Hit plus on your calculator, and you're done.
In my opinion,
That
this is
final
easier
answer-
than looking at
Wait,
the
I'm
graph.
sorry. No, mine first? And then,
In my opinion, this is easier than looking at the graphs.
It is, right? It is. But kids get confused. They think this is Y for some reason, and then they think this is X. I don't know why, but people mix them up, and then they lose reality, like what your base is. But right, they did all the work for you here. You are right, Naman. Sorry, who else was talking? Was it Jessica?
Yeah.
Okay, hi Jessica.
The answer, what is it called again?
It's the approximation to the area underneath the
Okay.
curve, right? Or the area of the curve is another way of saying the integral. Okay. Area is like our first grader way of saying it. Integral is all the additive change, the cumulative change. And that's what integral is. It's cumulative change. We're just adding all the changes. Why do they call it cumulative change? Because that's a change, that's a change. We're just adding up all the changes together. And that's how you. Okay, so please, hopefully you don't get too upset with me giving you guys 6. But again, as I showed you the trick, just use a freaking calculator. All right. But that's the idea. That's how fast you guys can be doing these problems. but understanding that these are just rectangles and just reading that grid. Now, what happens is the next part of this, I went ahead and gave you guys some definite integral practice. Okay, so these are just let's see, 7 problems here. Just taking the integrals. They're all a little bit different. Okay, up here, easy polynomials, just x squared, x cubed. Okay, we can do power rule easily. I think I gave you 3 questions like that. Over here, we end up with fractional exponents. Fractional exponents. So, oh my gosh, there's a fraction now. Okay, but we'll work through each of these style type of problems. The answers will be a little fractiony. Okay, it's okay. This is what they are. And I gave you guys again. This is going to be a negative exponent here, a negative exponent, or this is actually going to be ln here, natural log. Right, 1 over x is going to be natural log, and then we see a e to the x function. Right, so all these are slightly different, and then we'll work through them quickly right now. So you guys can have at least an example of each of these. Now, I gave you guys 1 problem of each type, just to, again, give you guys some more practice. And I just threw that into one of the easiest lessons in the world. Okay. All right, so let's go ahead and do a couple of these. For the first one, let's go ahead and take the integral first, and then we'll plug in our a and b value. So the integral of this will be x cubed over, I'm going to write 2 times 3, plus 4x squared over 2 plus 5x bar negative 5 and negative 1. Negative 1 to negative 5. Is everyone okay with how fast I did that integral? The rule is x to the n plus 1 over n plus 1. That's the integral of x to the n. Right. And we can plug in the negative 1. And then, so I'll do this one first. It'll be 1 over 6, negative 1 over 6. Plugging in negative 1, that'll be plus 4 over 2. Plus plugging negative 1, that becomes actually a negative 5. Subtracted by, plugging negative 5 in, it'll be negative 125 over 6. Plugging negative 5 would be plus 100 over 2. Plugging negative 5 minus 25. All right. So I actually plugged in the values into the equation. And you could probably figure that out. I'll just keep going. This becomes a plus. Careful, that becomes a minus. That becomes a plus, right? So if we add them together, we're going to end up with positive 124 over 6. This is really 50, right? And this is really 2. 50 and 2 become negative 50, becomes a negative 48. And I see negative 5 and positive 25 and going to be positive 20. I'm adding those numbers together. And this would be 6 goes into that number. It's 20 and remainder 4 over 6 minus 28. And then, so this is something like whatever that is. So what happens here is you can just use a calculator. You should probably have used a calculator right from the beginning. Save yourself some time. 20.
Negative 22 over 3.
Negative 22 over 3?
Yeah.
Like that?
Negative.
$28 minus, you can also leave it as a fraction. That's probably what will save you time. 124 divided by 6. Yep. And that's what you would just enter in your calculator. Oh, in your CUDA. Okay. Let's see. So this next one would have been 4, negative x to the 4 over 4 plus 2x cubed over 3 plus x. Then we're going to plug in negative 0 to negative 1. So plugging in is not a big deal, hopefully. If I just plug it, I'll just plug it in just so you can see. It'll be 0 over 4 plus 2 times 0 over 3 plus 0. So do we really need to plug in the 0? Nope. But make sure you do that subtraction sign. We're going to subtract the backside. Negative 1 to the 4 over 4 plus 2 to the negative 1 cubed over 3. And then minus the 1, right? We're just plugging in that negative 1, but we always subtract the top from the bottom. We subtract the top from the bottom. Okay, and that will give us some final answer. I'm going to take the integral real quick here. x5 over 5 minus 2x cubed over 3 minus 2x squared over 2 plus 2x. Plug in 1 and 0. And that should be pretty easy because there's just 0 there. So those aren't hard. They're not supposed to be hard. Just, again, practice so you guys can get the motions out. Now, I'm going to jump to the 1/3 one now, okay? Now, please do not overthink this. It's just 2. Okay, 1 over 3 plus 1, right? I'm going to write instead 3 over 3 to save myself some brain power, right? Plus 1 is just 3 over 3. That's going to be 4 over 3. So x to the 4 over 3 over 4 over 3. That's our brain power. Now, if you want to multiply by the reciprocal, do it. The reciprocal of this would have been 6 over 4, which you could reduce to 3 over 2. X to the 4 over 3. Plug in 0 and negative 3. That's the easy part, actually. The hard part is going to be you plugging in that negative 3. Algebra 2 sucks. Okay. All right. Doing the next one, I'm going to rewrite this as the integral of 1 to 3 of 3 over, not 3 over, I'm just reading it. X to the negative 2 power, okay? Negative 2 power dx. So I'm rewriting this negative exponents. I'm rewriting it so it's a fractional exponent. I'm changing it to a negative exponent on top. So we can just do our power rule. Negative 2 plus 1 is negative 1. Please FYI, negative 1. So this is 3x to the negative 1 over negative 1. 1 and 3. Okay, so once you get the rhythm of power rule, these are all just power rule. I'm going to purposely die on the next problem, okay? So if I rewrite this as the integral between negative 4 and negative 1 of x to the negative 1 power, I'm going to die on purpose, okay? So watch. Negative 1 plus 1 is 0. We can't do x to the 0 over 0. So this isn't a power rule equation. This isn't power rule. This is natural log. This goes directly to ln absolute value of x bar negative 1 to 4, negative 4. All right, so remember this is natural log. X to the 0 over 0 doesn't make any sense. We have a special rule for that. That's natural log. The last one. Okay, I'll give you guys a moment just to catch up there. The last one, as a reminder, the derivative of e to the x is e to the x itself. So none of these are what we're going to call use substitution. These are straight integrals, straight definition problems. Okay, we'll work on use substitution next time as we go through harder problems. So this is 3 e to the x, negative 3, and 0. If you want to double check, the derivative of 3 e to the x is 3 e to the x. Oh my gosh. Imagine if you show up to a blind date and it was your last date. You're like, oh, hi. It's you again. Great. Well, I gotta go. I got COVID. All right. So if you guys have any other questions, this is really what you guys were practicing. The first part, I think 9 questions maybe, it's just this table. Right? Just the table. So you guys can crank that up pretty easily. And then the last 7 are just review doing power rule or our straight integrals and plugging in the b minus a. Right? Again, you can use a calculator just to plug in that last part. It'll be good for you guys. All right, that's it. Easy peasy.